Okay guys, in this video lesson we're going to do additional practice with some dimensional analysis. So this is for you if you just feel like you need a little bit more work through this, a little bit more examples of that. So we're going to continue on with the notes in this into our next slide. So we have two more practice problems here. And the first one we see here is Lake Superior has a volume of 1.21 times 10 to the fourth kilometers cubed. Okay, so this is a volume, so we have cubed kilometers. What's the volume in milliliters? Okay, so now when we're working with a cubed unit, the trick with this is when you convert them, you have to cube all your conversion factors. So you can't just say that there is 1,000 meters in a kilometer. You have to say there's 1,000 cubed meters cubed in a 1 cubed kilometer cubed. Okay, so if we set it up, here's kind of how I would solve it. Again, I'm not going to do everything on the board with this one. We're just going to kind of walk through it. So here's my kilometers, and I wrote it not in scientific notation to see it. And so for every 1 cubed kilometer cubed, I get 1,000 cubed meters cubed. That way I'm canceling out kilometers cubed in my math, okay? Now when I put this in the calculator, I had to type in 1,000 cubed for the math to work out. And then I went from meters to centimeters. So my meters went down, my meters cubed went down. 1 cubed is just 1. To 100 cubed centimeters cubed. And then we know this conversion factor is one you can look up, that for every cubic centimeter we have 1 milliliter. So that's actually the definition of a milliliter, is taking a centimeter cubed. So 1 centimeter cubed is 1 milliliter. So now we've done all the work. Our kilometers have canceled, meters have canceled, centimeters have canceled. We have milliliters, and if we do the math, we have 12,100 times 1,000 cubed times 100 cubed. And so we're talking about cubed times cubed. So that's a pretty big number. And we end up with 1.21 times 10 to the 19th milliliters here. Okay. Next practice problem takes us away from measurements that we're used to and brings us into things that we're not used to apply the same concept. So we have, for every 2 Dorns, there are 3 Borks. It takes 5 NURBS for every 7 Tarns. Each Bork has 4 Tarns. If you have 120 NURBS, how many Dorns are there? Okay, so it's kind of a riddle, and people have solved these before, but here's a very systematic way to do it. So for every 2 Dorns, there are 3 Borks, so it's a 2 to 3 ratio. Here you have a 5 to 7 ratio, and here you have a 1 to 4 ratio. So those are just conversion factors. So we're going to start with the 120 NURBS, and we're going to put 5 NURBS on the bottom, 7 Tarns on the top, then move over and put 4 Tarns on the bottom, 1 Bork on the top, and then we're going to go and put 3 Borks on the bottom and 2 Dorns on the top to find Dorns. So if you see how we do that, here's all those relationships that was identified in the word problem. They're weird ones to us, but really is just basic dimensional analysis. So for every 5 NURBS, we had 7 Tarns. We want Tarns to cancel next, so for every 4 Tarns, there's 1 Bork. Borks need to cancel, so it goes down. So for every 3 Borks, there's 2 Dorns. So it's 120 divided by 5 divided by 4 times 2, and we get 28. Now, this idea is sig figs. Sig figs is a way of saying precision. So we're really not worried about precision here because nothing here is really measured. Okay, so that's another example one. Here we want to move on to some more to work with. So here we have a basketball hoop in meters. So if we're assuming exactly 10 feet, okay, the word exact here helps us out. It's not a measurement now. So we have 10 foot. So I'm going to go from feet. So I have 10 feet. So every 1 foot is 12 inches. And then this conversion factor, again, is one of those that's important to us to know and memorize, that there's 2.54 centimeters in 1 inch. And then we know for every 100 centimeters is a meter. So in 3 steps, we can cancel out and get 10 times 12 times 2.54 divided by 100 to get this. Bottom one, we have red light giving off a wavelength of 650 nanometers. What's that in miles? Okay, so it's kind of ridiculous that we're asking this, but let's see what happens. Red light is actually 650 nanometers. We do want to make sure we know there's 5,280 feet in a mile. So starting with nanometers, we know there's 10 to the 9th nanometers for every 1 meter. For every 1 meter, there's 100 centimeters. Again, there's 2.54 centimeters in an inch, 12 inches to a foot, 5,280 feet to 1 mile. And if we look, nanometers cancels, meters cancels, centimeters cancels, inches cancel, feet cancel. We have miles. So 650 divided by 10 to the 9th times 100 divided by 2.54 divided by 12 divided by 5,280, and we get 4.0 times 10 to the negative 10th miles on here. And MI is the appropriate abbreviation for miles. Okay. Now, there are 3 more that you can do in practice here and work workout. I will show you the answers to these only. If you want to do these on your own and practice them on your own, you can. So we are measuring a board, two sides of a board, and we want squared feet. So we have to multiply them first and then put it together. We have a density problem, and then we have Joe Mauer and his millions of dollars. Okay, so if you solve these, here's the answers you're going to get. Okay, so go ahead and write these down if you want to see an answer key, and then work through the math to see if you can match with the answers. Okay, if you want additional help with these, please come see me, and I can help you walk through and work through the problems with these. All right, guys, thank you.